Hey guys, welcome to our first day of, I guess, virtual learning for the 2020 school year. Um, Obviously, we hope to be back in person tomorrow, but if we're not, we're going to continue in this format for at least a little bit. If we end up moving to virtual on a more permanent basis or even a more regular basis, then we'll switch into the Blackboard stuff that we went over at the beginning of the school year. For now, though, because our chapters go in a little different order between Blackboard and the physical classroom, we're going to kind of just keep marching in the direction that we're at. So your expectation for today is that you would continue working on your chapter 2 packet. And as such, I'm going to kind of do a couple of examples of adding and subtracting and multiplying and dividing with significant digits because that should be the content area that we're kind of working on next. And if that's it, if you've got if you've watched the notes that I've already, or the video with the notes, and you kind of grasp the subject already, go ahead, you can shut this video down and get to work. But if you need a little extra guidance on sig figs, here we go. I'm going to apologize, by the way. I'm going to be looking off to the side for the most part because my document camera is over here. So, with no further ado, let's get to it. So, basic review first off on significant digits. Says that remember every digit is significant except leading zeros in a number with a decimal. With decimal. And trailing zeros in a number without. So everything is significant. Trailing, let's see if I can spell. Zeros in a number without a decimal point. And again, as examples, I could say that 0.0035, that these two first zeros are not significant. And if I had something like 53,000, and with no decimal point, I could say these trailing zeros are not significant. Everything else automatically yes. Okay, so that's a little bit of just general review on identifying significant digits. Now let's take a look at adding and subtracting. So in adding and subtracting, the rule is our answer can only be as precise as our least precise term. And let me get caught up as least precise term. And what I mean by precision is like what decimal place does it go down to? So if we had something, for example, that went down to the hundredths place, or something that we went that only went down to the tenths place, this would be less precise because it's not going down as many places. So we're looking for where's the last significant digit to the right, and whichever one is the least precise, so has the last significant digit furthest, I guess, to the left. That would be the controller of our answer. So let's take a look at this in practice a little bit. If I've got, say, 512, and I'm going to add 50 to it. As long as these are measured items, so we'll say centimeters, then we have to do these sig fig rules. If they're counted items, then it doesn't matter. You just do math the same way you've always done math. Those are considered perfect numbers, and these rules don't apply to them. But in this case, centimeters are measured values, and so there's some uncertainty in them. And what we're going to do is we're just going to add them together first off the same way you've always added. And we're going to say, okay, we get this raw answer of 562 centimeters. But now we need to do some rounding to it according to this rule. For adding and subtracting, the answer is as precise as the least precise term. In this case, the top number is precise all the way down to the ones place, but the bottom number, this is not a significant zero, so this one is only precise down to the tens place. That means that we have to round our answer to the nearest 10, and we would round this answer to 560 centimeters. The same thing goes for subtraction. If we had like 0.0434 minus 0.02, for example, we would go ahead and actually, I'm going to add a 0 there, 0.020, just to illustrate an extra point. And we would go ahead and subtract these two things. Our raw answer is going to be 0.0234. And now we're going to have to look at how do we round. Okay, and on the top number, we're precise down to the 10,000ths place. And in this bottom answer, though, we're only precise down to the thousandths place. Now, this 0 is significant because this is a number with a decimal, so only the leading 0 was not significant. The trailing one is. So we're significant down to this 3 places past the decimal point, and therefore we have to round our answer to that 3 places past the decimal point, and we would end up with this being 0.023. And that's it. Adding and subtracting with significant figures is just that easy. Really, you just have to look at what level of precision you have in your numbers and make sure that your answer is rounded to have that same level of precision. For multiplying and dividing with significant digits, we have a different set of rules, because why not? Multiplying and dividing. And really, again, this isn't just made up to make your lives hard. This is all about kind of preserving what digit is being guessed at, or what digit the uncertainty is, to make sure that whatever the last digit we're reporting in our answer, that digit is where the uncertainty lies, so that if another person looks at that, they know exactly where we guessed and what we measured, what we knew for sure, and what we guessed at. Anyway, multiplying and dividing, the rule is to count the number of sig figs in each term. And then the answer must have the same number of sig figs as the term with the least. So let's say that I've got some big number, 1, 2, 3, 4, 5, 6, 7. 1,234,567. And I'm going to multiply that by 2. And again, we got to make sure that these are measured numbers. Again, if they're counted numbers, you just do the math the same way you always did. But anyway, I've got this many milliliters, and I'm going to multiply it by 2. So I'm going to say, well, there's my raw answer, 2,468,134. But now I have to count in each of these terms how many significant figures did I have, and I gotta then round my answer so it contains the same number of sig figs as my least. So this top one, I have 1, 2, 3, 4, 5, 6, 7 sig figs. Everything is significant, but here down in the bottom, I only have 1 sig fig. And since in the bottom I only have 1 sig fig, I have to round my answer so that it only has 1 sig fig, and I'm going to round this to be 2 million. And this would be square milliliters. Okay. Let's take a look at another example. Let's say that I've got something a little bit tougher, maybe 0.0543, and I'm going to divide that by 2.12. Okay. And let's actually make that 2.120. Now we're going to take a look. First thing we need to do in multiplying or dividing sig figs is count the number of significant figures in each one of these. So we're going to take a look at this top one. There is a decimal point, so that leading 0 doesn't count. So in this term we have 3 sig figs. And here in this term there is a decimal point, so only leading zeros don't count. In other words, we have 1, 2, 3, 4 sig figs. And we're going to do that math, 0.0543, and we're going to divide that by 2.120, and we will end up with this raw answer of 0.025613208. And one of the neat things about chemistry as a class is you should never have to ask me where to round things to, because these rules are going to tell you where to round things to. In this case, again, I need to round it so that I have as many as sig figs as the least significant. That's that 3. So my answer needs to have 3 sig figs in it. Now there's a decimal point, so this is not significant, this leading 0. So I need 1, 2, 3 decimals, and I'm going to round to this place, to 4 places after the decimal point. Now it's a round, but in this case it happens to round down because that's smaller than 5, and so I would end up with this 0.0256 as being my correct answer. Hopefully that makes some sense. If there is any question about it, or you're having difficulty learning from this video or the other video that I did, you certainly are able to go into Blackboard. This would be chapter 2's material, which in Blackboard things go a little bit out of order chapter-wise, but I'm quite certain that the professor there has some videos on the same material explaining it from her perspective. Otherwise, another great resource to go to if you're struggling is Khan Academy. They have kind of a fully developed curriculum on chemistry and many other subjects that are taught via video. So you could just do Khan Academy, or literally you can just Google, math with significant digits, or adding and subtracting with sig figs, or multiplying and dividing with sig figs, and you'll get 1.5 million responses. So that being said, you are expected to progress through your Chapter 2 packet through the sections on adding and subtracting and multiplying and dividing with significant digits. I will go ahead and throw up an electronic copy of that note packet into the teams along in the classroom material section of our teams, so that if you didn't bring it home with you, that you would still have access to that. And on that note, I understand that, probably some of you didn't bring computers home or things like that. If you're getting this message but you're unable to work on this stuff for today, I definitely will be understanding. We're going to hopefully be back tomorrow and can get things caught up. If we're not back tomorrow, I'm sure there will be some arrangement made for allowing you people to kind of retrieve whatever you need to be able to function successfully. So don't have to check in with me today, but I will have a meeting running during our normal classroom hours in Microsoft Teams, in which I'll just have the meeting running so that you can just join. And if you do join and I'm not there present already talking with a kid, just give me a shout out, because I'll probably be doing something in my room with the volume up, so that I can hear you if you join the meeting, but I probably won't be sitting and staring at a blank computer. So if you join the meeting, let me know. Otherwise, I very much hope to see you people in person tomorrow. Please let me know via email if you have any questions or you need more examples or anything like that. I certainly can do, anything you need on that front. So hope you're having a great day. Hope we're back to normal soon. I look forward to seeing you, ladies and gentlemen, back in the classroom.